Modeling direct variation. Direct variation is the equation y equals a times x. It's always going to be in that form. Y equals a times x. There's nothing added to it. There's nothing subtracted from it. It's literally y equals a times x. Okay? Y is said to vary directly with x, which means y is affected by what happens to x. So you're inputting stuff to x, you're getting an output for y. It has direct variation. The non-zero constant, so what they're saying is a cannot be 0, is represented with a. That is considered your constant of variation. It's considered your constant of variation. So you have the equation y equals a times x. Y varies directly with x, and this a is considered your constant of variation. So when they ask for a direct variation model, you are giving me an equation that says y equals a times x. While you write that down, let me know when you're done, because I'm going to write
Why'd you say oh no?
some other stuff. This is not that bad. Drew just is.
This is like the gateway to the bad stuff.
Oh,
The game.
great.
So tell me when you have that done.
Nervous now, bro.
Welcome.
I'm nervous now.
I thought it was on to
Okay, so with that being said, we're going to create direct variation equations and models. Now, this takes some work and effort. So it says write and graph a direct variation equation that has -4/8 as a solution. Okay, we want to get it into that y equals ax form, where y and x don't have any numbers plugged in, just a does. So if I have the point -4/8, okay, I can use that information to figure out what a is. How do you think I can use that information to figure out what a is? What do you think I do with -4 and 8?
plug
Plug it
in
To the y and x. So I'm going to plug it in so that it says 8 equals a times -4. Okay, how do I get a by itself?
Divide by -4.
Divide by -4 and a equals.
-2.
That is not my equation though yet. My equation, this then has to be transferred it back into y equals -2x. This is the equation they're looking for.
So it's the 2-step.
So it's a two-step. Okay? So once you solve for a, you're not done. I literally want you to plug it back in to say y equals -2x. Now we're going to graph that. What is your y-intercept?
You don't have one. 0.
0.
0. And you should never have 1 in this, because there should never be anything added or subtracted to this. If there is, it's not direct variation. Okay? So they might give you a trick question and say, is this direct variation? Explain why or why not. Well, if there's something added or subtracted to it, it's not direct variation. It's in linear form, or y equals mx plus b. So I'm going down 2, right, over 1. Or I can go up 2 and that way on. And then I graph my line. Okay, and that's all they're asking me to do for that. Write and graph that. Let's try one. Well, let's try this problem. This is a word problem. I drew the picture on the board and we can go from there. It says, hailstones form when strong updrafts support ice particles high in clouds. where water droplets freeze into the particles. The diagram shows hailstones at two different times during its formation. Write an equation that gives the hailstone's diameter after t minutes if you assume the diameter varies directly with the time the hailstone takes to form. So the diameter varies directly with time. So if the diameter varies directly with time, what is my d and t represent? Is it my y, my x? Which one's which?
I think
D would be the Y.
Would be the what?
Y.
Yes, because
Oh, darn.
d varies directly with t, y varies directly with x. So d is my y in this case. So my equation says d equals a times t. Now, how do you think I can solve an equation for that? What can I do? I need to come up with an equation. So,
Put in 7.5 for Y.
okay,
Or
For-
3 and 12 for T.
and 12 for t equals a times 12. So I'm going to divide by 12, and 0.75 divided by 12 is going to give me what my a is. So you should get a decimal of 0.0625.
Oh. 0.06.
What?
You divide
0.06.
0.0625. Did you just get
7.5
0.0?
divided by 12 equals 0.625.
I got 0.6.
It's 0.0625.
Actually, no, I don't know.
You did 7.5, not 0.75.
Oh,
I got
I wrote it down.
0.065. I got that.
So then, what do I have to do with that information?
Plug it back in.
So I have to say, this is my equation. D equals 0.0625 times T. That's my equation. That's part A. Part B says, after T using your equation from part A, predict the diameter of hailstones for the 20-minute one. So what am I going to do with that?
Multiply the A by 20.
Yeah, multiply the A by 20. So I say D equals 0.0625 times 20, okay? .0625 times 20, and you get what? The diameter to be 1.25. I think these are inches. I don't know what they are. Yeah, inches. So now I can predict, or I can figure out and compare things because I've used two different diameters and equations. Practice a few more of these things.
Yeah, you can still find it.
Direct variation, okay? Ratios go with direct variation. Okay, so you can set up a ratio to figure out what your direct variation is. Because the direct variation equation is y equals a times x, you can rewrite the equation, okay? This equation says y equals a times x, but if I divide by x, I would rewrite my equation to say y over x equals a. This can be your ratio, okay? If you are comparing data with direct variation, comparing different equations of direct variation, if they have the same ratios, they're going to be able to be equivalent or create the same type of equation because they are varying directly by the same thing. Okay? So it shows direct variation in a ratio of y to x is the constant. If your constant comes out to be the same thing, you have the same equation. So in data, sometimes they'll compare things. In the book, the example is about sharks, how the length of a shark's tooth compares to the length of the shark's body, okay? So it varies directly, the tooth length varies directly with the body length, okay? And because of that, you can set up ratios. If, in this case, you look at all the ratios and they're within a number or two, they're gonna say that that's the same thing, because it's big data, okay? The smaller the data, the closer the numbers need to be. So if it's within a number or two, like, all the data they use is within like a number of 119 to 120 or 121, then I would say, yes, that's close enough, I can use that information, which we might have to do. Okay, so they give you data like this. 1.8 to 15. And then, let's see here, 2.4 to 90. 2.9 to 350. 3.6, 430. 4.7, 565. And 5.8, 695. Okay, and this is the tooth length. And this is the body length. So this is my X data and this is my Y data, okay? And they want to know, off of this data, it says great white sharks have triangular teeth. The table below gives the lengths of a side of a tooth and the body length for each of 6 great white sharks. Tell whether tooth length and body length show direct variation. If so, write an equation that relates the quantities, okay? So what we have to do is we have to set up the ratio. So it's y over x. So I'm going to say 215 over 1.8. What does that come out to be congruent to? 215.
119.
Okay, so 119 if I round. And then I'm going to do this for all 6 sets of data. 290 over 2.4. 121 if I round. 350 over 2.9. 121 when I round. 430 over 3.6. Which is 119 when I round. 565 divided by 4.7 is 120 when you round, and 695 divided by 5.8 is 120 when you round. So those are all within 2 numbers of each other, okay? They're all very close, and we're dealing with like large things such as a shark's body length. So that is good enough to say that the ratios are close enough that I can create direct variation off of that. So to create direct variation off of that, I'm literally going to choose any of these points here, okay? If I were you, I would choose one of the ones for A, because we just solved for A on all of these, yes? I would choose like 120 because it's in between both 121 and 119. So your equation would say y equals 120x. And I've created an equation for direct variation off of the ratio, okay? And so then I can predict things from there. It says, yeah, so I can predict things from there, and you can decide if the direct variation equation, so if they said, okay, the tooth length is now 6.7 inches, okay, then you could plug in 6.7 to x and figure out what approximately the body length would be off of that. So direct variation is very nice because everything depends on the other. Y depends on what x is, so it makes it simpler. That's what this is about.